A relation R in a set A is equals to 1, 2, 3, 4, 5, 6 defined as R is equals to ordered by x comma y such that y is divisible by x. Again we need to check whether this is reflexive, symmetric and transitive. Reflexive, I will consider the condition for reflexive. Here the difference is actually the set may be given as Z, R or anything. Here set A is 1, 2, 3, 4, 5, 6. So reflexive. For reflexive we need to consider x comma x. So what is x comma x? This x is divisible by x, which is true because every number is divisible by itself. Therefore x comma x belongs to R for all x belongs to A. Hence we can see this relation is reflexive. Next, symmetric. So symmetric means x comma y. What it implies? Y is divisible by x. So if y is divisible by x, then not necessarily x is divisible by y, because in this example only we can say this 4 is divisible by 2. 4 is divisible by 2, but 2 is not divisible by 4. 2 is not divisible by 4. The result holds good means it should hold for every number. You can say we have element 2. 2 is divisible by 2. Then again if you consider 2 is divisible by 2. But to be symmetric, it must satisfy for all. If you have a single example that does not satisfy the conditions of symmetric, then it is not symmetric. So next we need to prove it is transitive or not. So transitive means x comma y belongs to R, y comma z belongs to R. What x comma y belongs to R means? X comma y means y is divisible by x. Then what is y comma z belongs to R means? Z is divisible by y. Therefore you can clearly say z is divisible by x, because you see here, if this 3 is divisible by 1, y is divisible by x, I will consider the ordered pair 1 comma 3. 3 is divisible by 1. Similarly I will choose 3 comma 6. 6 is divisible by 3. Therefore obviously this 6 must be divisible by 1 also. 6 must be divisible by 1. This is not only for a single element, because so you cannot give these examples to prove this. You can give examples for disproof, but you cannot give example for prove. But I have taken this for the purpose of understanding. Therefore z is divisible by x means ordered pair x comma z belongs to R. Hence we can say this relation is transitive and reflexive but not symmetric. This is not symmetric because x comma y belongs to R does not imply y comma x belongs to R.